This is Chapter 2, Review A. We're going to be doing a couple of the even problems from numbers 2 to 24. The other even problems in the chapter review will be Chapter 2, Review B, but this is the first part of Chapter 2, Review A. So let's go ahead and start with question number 2. And it says, state the domain and range of each relation and whether it is a function. So the first circle represents your D, your domain, your X values, and your second circle represents the range or the Y values. So our domains are simply going to be 3 and pi, and the range values are going to be simply 2 and 7. So there's your domain and range. And it also says state whether it's a function. Well, it's a function if your domains are not used with more than one range. Right, the 3 is matched up with the 2 and 2 only. It's not matched with the 2 and the 7. The pi is matched up with just the 7, not the pi and the 2. So we would say, yes, this is a function. Moving on to question number 4, state the domain and range of this inequality. Well, our domain would be our x values. We can plug in any number that we want to for x. It doesn't matter what we plug in. We can plug in anything we want to. So we'd say all real numbers. However, when we talk about our range is going to be not just all real numbers because y has to be greater than x. And x, since it has absolute value symbols, is always going to be positive. So we're going to have to say, well, y is always going to have to be greater than 0 in this case. And then we have to determine if it's a function or not. Well, I can let x be equal to 2. And if x is equal to 2, well, the absolute value of 2 is 2. So as long as y is bigger than that, how about it be 3? That's true. What about when x is 2? I could let y be 4. And we could already see, it can have the same x value matched up with different y's. So this would not pass the vertical line test if we were to graph this. So this is not a function. Moving on to question number 6. We're supposed to evaluate each function for the given values and then express your answers in function notation. Alright, so what we're going to do is simply just plug in these values. So when x is equal to negative 2, what do we get? Well, we say, alright, 2 times negative 2 is negative 4, and negative 4 minus 10 is negative 14. So when x is negative 2, we get negative 14. When x is 0, so f of 0, we get 2 times 0 minus 10. 2 times 0 is 0. 0 minus 10 is negative 10. So 0, negative 10. And then when x is 5, so f of 5 is equal to 2 times 5 minus 10. Order of operations, multiplication first. So 2 times 5 is 10, and 10 minus 10 is 0. So those are 3 values when we plug in the 3 values that were given to us for x. Let's move on to question number 8. Question number 8, we have this greatest integer function, and so what we have here is this greatest integer. If you think about it, when we plug in negative 1.2, it's 2, and the greatest integer of this. Let's just show you what this means real quick. When I have my number line, negative 1.2 is about right there somewhere. So it's an integer that cannot be greater than that number that we have. So the integer that cannot be greater than that, the nearest integer, is negative 2. So this is simply 2 times negative 2, which is negative 4. On the next one, when we plug in 0.9, alright, on a number line, 0.9, if we're taking a look right here, it'd be really close to 1, but it can't be 1 because it can't be an integer that's bigger than that number. So the greatest integer is not bigger than that point is actually 0. So this is just 2 times what's going to be 0, 2 times 0, which is simply 0. And then when we plug in the fraction 9 over 2, so 2 times the greatest integer of 9 halves. 9 halves is the same thing as 4 and 1 half. So not going past that point would just be 4. So 2 times 4, which is 8. Moving on to question number 10. says find the slope and the x and y intercepts of each graph. So in order to find the slope of this equation, I want to put it in this form, y equals mx plus b, where m is my slope. So if I want to do this, let's solve for y. So I get negative 3y is equal to negative 4x minus 12. Divide everything by negative 3. And so y is equal to negative divided by negative is positive. 4/3 x plus 4. And what's really I need is this number right here. So my slope is going to be 4/3, or 4/3. Now, in order to find the x and y intercept, you simply let the variable equal 0. So to find the x, let the y be 0. So I get 4x is equal to negative 12. So divide by 4. So x is equal to negative 3. So my x-intercept is negative 3, 0. And then for my y-intercept, let my x value be 0. Oops, that shouldn't be an equals. Minus 3y is equal to negative 12. So negative 3y is equal to negative 12. So when you divide by negative 3, get y is equal to 4. And so my y-intercept then is the point 0, 4. There's a lot of work. I'll try to put it organized so you can see that. So my slope is 4/3. My x-intercept where it crosses the x-axis is negative 3, 0. And my y-intercept where it crosses the y-axis is 0, 4. Let's move on to question number 12. Question number 12, I am to graph this equation that's given to me, 3x plus y is equal to 7. Now, there's different ways to graph it, but when I graph it, I want to put it in slope-intercept form. This is just really easy to graph if it's in this form. So you know your y-intercept, you know your slope. So that means you need to solve for y, which is going to be fairly simple in this one. So y is equal to negative 3x plus 7. So my m is negative 3, or negative 3 over 1. I like to make it a fraction. And my y-intercept, where it crosses the x-axis, is the point 0, 7. So let's go up to 7. 1, 2, 3, 4, 5, 6, 7, right there. And then from there, I need to rise negative 3. So down 3, 1, 2, 3, and run 1. And so put a point. And then connect straight as a line as you could possibly get. Sorry for my not being exactly on the lines there, or on the points. And so there is your slope. And you can tell it's a negative slope, very steep, as you look at it from left to right, negative going down. Move on to question number 14. We're to graph this equation. Just treat the f of x as like it's a y. Alright, so if you want to replace it with y, you can. So y is equal to x minus 2. Think of it that way. So m is equal to 1 over 1. And my y-intercept is 0, negative 2. So it crosses the y-axis at negative 2, right there. And then we know the slope is rise over run, so up 1 over 1. So up 1 from that point and over 1. And then simply connect. And there is the graph of question number 14. Moving on to question number 16. This one says, write the equation of each graph line in slope-intercept form. So slope-intercept form is y equals mx plus b. Okay, so important. Now, this is kind of like working backwards from the ones we just now did. They gave us the equation and then we graphed. This time they give us the graph. We got to come up with the equation. So when we do this, we need a couple things if we can. We need the y-intercept if we can, and we need the slope if we can. And the problem is I don't see where it crosses the y-axis on this graph. All right, so we'll have to do a different way here, but let's see if we can at least figure out the slope. In order to find out the slope, you need at least 2 points. All right, and you can see I got a point right there, and I got a point right there. So let's see what the slope is. All right, so starting from this top point, I would have to go down 1, 2, 3, 4, 5, 6, 7. So I'd have to go down 7 and to the right 2. So my slope is negative 7 over 2. Now, in order to find the y-intercept, I would like to just look at the graph and figure out where it crosses the y-axis, but I can't tell by looking at this graph. So what I'm going to have to do then is use my point-slope form. All right. So when I use my point-slope form, that is y minus y1 is equal to m times x minus x1. And I'm just going to choose this point right here, 1, 2, so that's 2, 3, as my point. So I have y minus 3 is equal to slope, I found that out, times x minus 2. So distribute y minus 3 is equal to negative 7 over 2x, and negative times negative is positive, and the 2's would cancel, so just 7. Then add 3 to both sides, and then bring this up right here. Y is equal to negative 7 over 2x, which I knew that was my slope, and then my y-intercept, it crosses the y-axis at 10. Alright, so in slope-intercept form, y equals negative 7 over 2x plus 10. Moving on to question number 18. Question number 18, we have the line passing through 2, negative 1, and negative 2, 7. So we have a line that goes through these 2 points. Now I don't have a picture of the graph. I guess I could graph it if I wanted to and then try to figure out what the slope and the y-intercept is. Or you can simply just find the slope by saying, well, slope is y2 minus y1 over x2 minus x1. And I like to label, so x1, y1, and x2, y2. So slope is equal to 7 minus negative 1, so it's 7 plus 1, negative 2 minus 2. So I get 8 over negative 4, or negative 2. So my slope of this line is negative 2. Now, once you know your slope and you know a point, you use your point-slope form. So it's y minus y1 is equal to m times x minus x1. All right, plug in your values. So y minus negative 1, same thing as plus 1, is equal to m, I figured that out, x minus x1. And so, moving up here, I have y plus 1 is equal to negative 2x, and negative times a negative is plus 2 when you distribute. And then lastly, subtract 1 from both sides, so I get y is equal to negative 2x plus 1. And as I was looking at that problem, I completely distributed wrong. All right, negative 2 times negative 2 is plus, but negative 2 times negative 2 right here, this should be a 4. Sorry about that. Sometimes I make mistakes, going too fast. Gotta go slower next time, David. So that's going to be 4 minus 1, which is plus 3. Sorry about the confusion. All right, so y is equal to negative 2x plus 3. That's in slope-intercept form. Moving on to question number 20. This time we have a line that passes through negative 10, and this should say negative 3. Make sure to do the same problem you all are doing. And parallel to 4x minus 5y is equal to 25. All right, so if it's parallel, it means it has the same slope. So I need to figure out what the slope of this line is first, and then I'll know my slope. So I'm going to put this one in slope-intercept form. And we divide by negative 5. This one in slope-intercept form is 4/5 x minus 5. So what really concerns me is that number right there, the 4/5, because if it's parallel, it's going to have the same slope or equal slopes. So then my slope is 4 over 5, and again I have a point. So I'm going to use the point slope form. So I have y minus negative 3 is plus 3 is equal to 4 over 5 times x minus negative 10, so it's plus 10. So I get y plus 3 is equal to 4 over 5x, and then when you multiply, this would cancel and distribute, and that gives you 8. And then lastly, I want to subtract 3 from both sides. And so y is equal to 4 over 5x plus 5. And that's in slope-intercept form. Let's move on to question number 22. 22, I'm supposed to write the equation of each line in standard form. So not slope-intercept form like the previous two problems, but in standard form. And on this one, 22, it's going through the point 2, 4, and has a slope of 3. So I already know that it looks sort of like y equals 3x plus something. All right, but I'm going to use my point slope form when you know the point and the slope. So y minus 4 is equal to 3 times x minus 2. So y minus 4 is equal to 3x minus 6. Add 4 to both sides. You get y is equal to 3x minus 2. Now that's in slope-intercept form, but I'm supposed to put it in standard form. So I need my x and y's on the same side. So when I do that, I would subtract 3x from both sides. And you're not supposed to have a negative coefficient to x, so multiplying everything by -1 changes the signs. So 3x minus y is equal to 2. And this is in standard form. X and y is on the same side, no fractions, and your coefficient to x is positive. And the last one for the review A, question number 24. We are to put it in standard form, and it passes through the point 3, -7, and is parallel to y equals 2/3 x plus 7/4. Now I like this one already because they already put this one in slope-intercept form, and so there's my slope. So I know my slope is the same thing since it's parallel. Parallel lines have the same slope, while perpendicular lines have negative reciprocal slopes. So I'm going to use point slope again. So y minus y1 is equal to m times x minus x1. And so I get y minus -7, same thing as plus 7, is equal to 2 over 3 times x minus 3. Distribute. So y plus 7 is equal to 2 over 3x. And the 3's would cancel there. When you multiply the fractions, you get minus 2. Alright, subtract 7 from both sides. So we get y is equal to 2 over 3x minus 9. Now, I'm not supposed to have x. This is slope-intercept form, but I want x and y on the same side. Alright, and I'm not supposed to have fractions, so I'm going to go ahead and multiply by common denominator here to get rid of fractions. So that gives me 3y is equal to 2x minus 27. Now get your x on the left side with your y, so subtract it. And then lastly, you can't have the negative coefficient, so multiply everything by -1. So it's 2x minus 3y is equal to 27. And this would be in standard form. So that concludes Chapter 2 Review Part A. Go ahead and watch Chapter 2 Review Part B for the second half of the problems.